Hey everyone, and welcome back. Ready to dive into some more fascinating ideas from the world of math.
Always excited to be here.
Today, we're going to be tackling something that's all around us, but that we don't always think about.
Yeah, like how do we actually represent 3D shapes when we're stuck in a 2D world?
Exactly. Like when you see a drawing of a cube, it's just lines on paper, right? But our brains can still see it as this, like, solid object.
Right. And the material we're looking at today delves into that, starting with a really simple example, a box of sweets.
Oh, yeah. Like Ramya and her box of sweets on page 126.
Exactly. It might seem basic, but it perfectly introduces the idea of nets. It's like, imagine unfolding that box completely flat.
Oh, so all those sides would be connected, kind of like one big piece of paper.
Yeah, and that's your net. Basically a 2D shape that you can fold along its edges to make a 3D object. It's like a blueprint.
Makes sense. But I guess not every shape you can draw on a piece of paper is going to magically fold up into a box, right?
You got it. It depends on the shape's properties. The number of sides, the angles, even how long each side is, it all matters.
It's like a puzzle almost, figuring out which shapes work.
It is. Remember those 5 square puzzles we talked about before? Well, some of those shapes can actually be folded into open boxes.
Open boxes.
Yeah, like a box without a lid. But not all 5 square shapes work. It's not just about having 5 squares, it's also about how they're connected. Their edges and corners have to line up just right.
So you got to think about how those squares fit together in 3D, not just how they look when they're flat.
Exactly. And that kind of thinking, that spatial reasoning, is something we use all the time.
It's true. Like packing a suitcase efficiently, you got to think about how everything fits together in 3D.
Exactly. And speaking of fitting things together, let's shift gears from tiny boxes of sweets to something a bit bigger. Let's talk about houses.
Houses. Okay, now we're talking. That feels a bit more complex than my box of sweets.
It is, but the same principles apply. Remember how we were saying that nets are like blueprints for boxes?
Yeah, kind of like a set of instructions for how to make the shape.
Exactly. Well, when we think about houses, we often use floor plans.
Right, like those overhead views you see that show you where all the rooms are.
Exactly. And just like a net, a floor plan is a 2D representation of a 3D structure. The material actually gives us an example with Vibha's house on page 128.
Makes sense. But, thinking about it, if you only had a floor plan to go by, all houses would just look like flat squares.
Exactly. A floor plan alone can't show the height of the walls or what the roof looks like, all those things that give a house its actual shape.
Right, all those 3D features. So how do we show that extra dimension?
Well, that's where deep drawings come in, which our sources talk about.
Deep drawings. It makes me think about trying to draw a cube, to make it look 3D on a flat piece of paper.
It's a good comparison.
There's definitely a trick to getting those lines and angles right. And our material shows a bunch of different attempts at drawing a cube, some way better than others.
And there's a reason some work and some don't. Creating the illusion of depth in a drawing, it relies on certain conventions, techniques that artists have figured out over time. It's not something we automatically know.
So it's like learning a specific way of doing it.
Yeah, exactly. Think about how we actually see depth in real life. Things that are farther away, they look smaller, right? And parallel lines, they seem to get closer together the farther away they go.
Right, like when you're standing on a straight road, it looks like the sides of the road are going to meet in the distance.
Exactly. That's perspective. And artists use things like vanishing points to make that same illusion on paper.
So they're kind of tricking our eyes into seeing depth.
Exactly. And these techniques, they're everywhere. Technical drawings, Renaissance paintings, we see them all the time without even realizing it.
Wow, it's like a whole visual language we've learned without knowing it.
That's a great way to put it. It's like learning to read. Once you get it, this whole new world opens up.
So we've gone from those sweet boxes to figuring out how to draw a 3D house. What's next? We're not going to try and draw a whole city, are we?
Not quite a city. But what if we tried building something? Our sources actually have this cool activity where they build a bridge out of matchboxes.
A matchbox bridge. Okay, that I can get behind. So much easier than trying to draw one. Tell me more. How does this activity work?
So the material describes how this kid, Navin, builds a bridge out of matchboxes, right? And then he and his friend Pratija try to draw it.
Sounds fun.
Yeah, but here's the thing. Navin's drawing, it only shows how long and how tall the bridge is. It doesn't show how wide it is.
Ah, I see. So even though he built it himself, his drawing is missing some information. It's kind of like, back to the house example, if you only had a floor plan, you wouldn't know how high the rooms were.
Exactly. One viewpoint can only tell you so much. Just like with the house, where we needed both the floor plan and that deep drawing, we need multiple perspectives to get the full picture of a 3D object.
Okay, that makes sense. So how do we get those different perspectives with the Matchbox bridge?
Well, imagine yourself looking at this bridge. You could look at it from the top, right? Or you could stand in front of it and see the front view, or even look at it from the side. Each view gives you different information.
And that's where the top view, front view, and side view examples in the material come in.
You got it. It's like having a set of viewing instructions for the bridge.
And when you put all those views together, that's when you can really start to see the whole thing in your head, even if you can't see every side at the same time.
Precisely.
You know, this is making me think about how important different perspectives are, and not just for like geometry and design, but for everything. Like we all see the world in our own way, right? And it's when we try to understand those different viewpoints that we get a better understanding of, well, everything.
Absolutely. Couldn't have said it better myself. So next time you see a cardboard box or a building or even just a drawing in a book, remember you're seeing a 2D version of something that exists in 3D.
It's like a secret code we've learned without realizing it.
And once you start noticing those different viewpoints
Yep.
and how they all fit together, it's like you can see the matrix.
Totally. Well, we've covered a lot of ground today, from those sweet boxes to drawing cubes to building bridges out of matchboxes. And it's all about understanding how we make sense of the 3D world around us.
It's been quite a journey. And, it's just the beginning. There are so many cool shapes and structures out there just waiting to be explored.
So true. Maybe this weekend we'll all be inspired to build our own Matchbox masterpieces. And if you do, be sure to share some pics. Until next time, keep those brains buzzing, and we'll see you on the next Deep Dive.